Alright, welcome back folks. Today will be my 8 days of doing the Leetcode commitment. So the Leetcode problem is the JMK 3. But I've never solved the JMK 1 and 2 in my life before. So let's check the problem together. We are given an array of non-negative integer arrays. We are initially positioned at the start index arbitrary that was given by the method. So in this array, when we are at the index I, we can jump to the I plus array of index or I minus array of index. That makes sense. We have to check. We can reach any index with value 0. So given that, we have to switch or jump from the given array to the 0 index, not the 0 index, the value of 0 in the any of the array. So we can think like there will always be the value of 0 in the array. And then there's a one notice, we are not allowed to jump outside of the array at any time. So if we check properly, I have prepared something for you guys. So let's see, like we are given like array of 4 2 3 0 3 1 2, which is written here. Let's see this as a value. So these are the values with green color, and then these are the index. So given that we have initially positioned at the start index 5, which is value of 1. So we can do the do move. What are those? So we are at the index of 5 plus array of index, which is also 5, which is 1. So we can jump to the index 6, or we can jump to the index 4. How do I know index 4? Because minus 1, so this value index 1. Okay, let me highlight this for you guys. This area came in from this portion in here. So if we detect that, that will be the index value of 4. So let's consider we are allowed to go there. How about we switch these? So we have two options at the moment. From 1, we are allowed to switch to there and there. So by checking that, from 2, we can jump to 2 place. So by given an error, given the XML 1, so we have the index 5, which jump to the index 4, which is here. Let me move my index cursor to here. So let's follow the XML first before we invent our wheel by ourselves. So index 4, from index 4, we are allowed to jump 3 index 1, 2, 3, which will be here, index 1. From index 1, we are allowed to jump 2. Why 2? Because 2 is the value of the index 1. So 1, 2. That's what we got for the answer of value of 0 at index 3. So what about we check the index 6? So from 1, we switch to index 6 or jump to the index 2. So that will follow the previous part. So by thinking of that, the only dataset that came to my mind is we definitely need to use the dataset like Q, because that will allow us to keep track of which data we have done in the past. Let's put the start in the queue first initially, and then I'm gonna keep the one thing called index to keep track of how many index we have done so far. Okay, so I'm gonna check like why index is less than to the queue dot count, because the queue in here will be always expanding whatever we have switched to another index. So let's call the current will be queue of index, that is index 0 initially. And and then we're gonna increment the index by 1. So by increasing the index 1, we are technically just doing the index 1, not related to the any of this jump into the I plus array of index or I minus array of index. And then what I want to do is I want to check, what if we are so lucky and we are positioning it at the start index is, let's say in here 0, 1, 2, 3, start index is 3, and we are done with the problem. So if our array of, let's call current, the current means the current value, so we're just getting the index from here, and then is equal to the 0, you just simply return the true. If not, return false. So we have done this. Next is we're gonna go through all the way in here. So by seeing that XML, I will write in the different color. So we are originally positioned in here. So what I want to write is from 3. Okay, I will draw the positioning of 3 with the blue color. From 3, we was, I need to change a little bit. From 3, we are allowed to switch like 1, 2, 3 from there, and then 1, 2 there. I think I better draw with the arrow, would be much easier. 3, 1, 2, 3, so like this. And then 2 to the 0, it's like this. So that's how we switch. So the same for the 2. For the 2, we will switch from, let's use something called red color to represent the 2. From 2, we will switch from here to there. So that's technically like we are going to the place that we have done in the previous approach before. What I mean by previous approach is index 4 approach, because if we hit the 3, 3 gonna jump to 2, 2 gonna jump to 0. I think for that case, the best data set that came in my mind is using the set. Let's go visited of the set of integer initially empty. So what I want to do is I will check that visited contain our current mean our previous value. If already contained, we can skip the whole iteration loop. And what we're gonna do is I'm gonna put that value into the visited, which is a current. So that is where the real valuation came in. Let's call forward, which will be this one. I'm gonna copy and update it in here. Current and array of current. Next will be backward. So backward is technically going to back, and we have done so far. And now what I want to do is I will check both the backward and forward is within the range, because in here we're given like we are not allowed to jump outside of the array at any time. So what I want to check is if our valuation forward means we're jumping, stay greater than or equal to the 0, and backward, okay, I need to check both, I guess. Let's check the forward first instead of like check both forward and backward. Forward, it's still less than the rate of count. So technically we can't be same valuation at rate of count. That will be out of scope for sure. So if yes, I'm gonna put into the queue with the forward. I think the same for the backward. So backward, and this also the backward. So I'm gonna append the backward in here, just a little bit of copycat in here. Yeah, I think it's pretty much done with that. After that, if we have Q, we're gonna get the index, and then we're gonna iterate it through. At the end, we get the answer. So let's go through with the example 2, which is given here. So let's consider that we are initially at the start of the index 0. So we are allowed to switch to 4 index, 1, 2, 3, 4. Now we're here. So technically we're allowed to go 3. So it's for sure like we can go to the right side, because right only have 2 values. We're gonna go like to the left, which is backward. So 1, 2, 3. We are now at the index 2. So from index 2, we switch to the 1, 2. So that's why it's written true. So let's check the example 3. We are initially at the index 2, which is here. So why we need to use the 2 type of data structure like Q and visited? So if we have both Q and visited, we will keep track of like not jumping inside the array forever, because we have keep track of which value, which index we have visited before. So let's consider we originally at the start of the index 2, so we are allowed to switch to 3 place, which kind of 2 place. So 1, 2 or 1, 2. So going to 2 doesn't make sense because it will loop as forever. What I mean by loop as forever, so you can see like from 2 we are jumping from 1, 1, 2 in here. Let me draw something. We are jumping like 2. Wait, why I can drop it? This is okay, makes sense because of the opacity. So we are jumping like 1, 2, like back and forth. So we will drop that approach. What about jump to the 3? So 1, 2, 3 will drop here. So 1 only can go to the left and right, right? So go to left is 2, go to right is also 2. So we were stuck in that loop forever. And then when the index out of bound, so we will hit the index is greater than the Q count, and then we're gonna hit the while loop end, and then that will help us to return the false. Let's try to see our current approach is working properly or not. Alright, what is happening in here? Oh, typo. Okay, should be the index. Let's try to run first before we submit the answer. I guess it's typo again. I'm not sure why I make so much typo in this median problem. My gosh. Let's check. Right, silly me. The visited should be the var because it is constant if we set the let. Alright, after a lot of typo fix, so technically we solved most of the problem. If I'm not wrong, we're using the O of n for both space and time complexity. Let's check together. Alright, it's big, the 75% for the time complexity, and for the space complexity, it beats over 54% of the today's submission people. Alright, according to my assumption, my time complexity is O of n and the space complexity is also O of n. Alright, that's pretty much for it, and I'll see you in the next one. Bye!